Welcome to the module 2. Now we are going to learn about the birthday paradox. So basically in this we are going to analyze the codism. So, so the birthday paradox says how many people you will invite to a party to know that more than one person or at least more than 50% people will have more than one person will have the birthday on the same day. What is the probability to do like that? So with the experiment they have found, if you are inviting 23 people, then there is a chance that you will get the you have more than 50% chance that two-person will have the birthday on the same date. This statement is called as birthday paradox. So using the concept of birthday paradox, so let's say how the birthday attack can be performed here. So basically the idea of birthday paradox they're using to find to like to the same concept they're using to forge a signature of a particular person. Like the intruder, they're trying to do some attack, and this is basically identified first time by the Yuval, who found that if your hash length is less than 128 bit, then there is a chance that a person can find your original text by breaking the hash code. So in this particular example, in a birthday attack, the malicious individual whose name is Malok is trying to forge the signature of victim, which is Alka, and the Malok is trying to get the signature on a fake document which is claiming a very high amount from Alka. So in this he will assert a message that Alka has to pay several million rupees, but exactly it is not the same. He's going to forge. So you might have seen in various movies where how the people get the forged signature, they'll be signing on multiple documents where, and out of those, one document will be useful for the intruder. In the same way they are doing here. Okay, so to do that, what Malloc will do is he create million of documents which are like F1 to FM, and all are the clone of F. So basically what they will do is in each clone he will provide the extra space, in between two words they will put multiple spaces. Okay, let's say if there are 300 words in document F, which is your original document, so there are 2300 ways which extra space may be left between the word. Later on he will compute the hash of each documents, each clones. Okay, now what he will do is he will generate one he will take one document D which seems to be fine, and people will not hesitate to sign on that is being signed by the Alka. And again he creates a million of clone of D which range from D1 to DM. Again he compute the hash code of each clone document. Then Malloc asks Alka to sign on the document, which Alka obliges. It means because the document look valid and it's very general and anyone can sign on this. So she also is signing on that document. Okay, later after getting the signature, Malloc accuses in future that Alka has signed on the fraudulent documents claiming million of rupees. So in this way, he is obtaining the digital signature in encrypted form, where he get the private key of signer. So let's say the Alka signature is DJ, and which is exactly same as FI. So here we'll obtain the signature from one document, and he will use for the another one. And since Alka has signed on document D, and same signature, digital signature is used by the Malloc, and stating that Alka has signed on the huge amount which she has to pay to Malloc, which is actually the original document F. So this is the way he can obtain the digital signature on the fraudulent documents. Now, how to make it secure? So to make it more secure, they have proposed an algorithm which is called as secure hashing algorithm. So let's examine now. So if you look at the input, what kind of input is basically provided to a hash function? We are just providing message in a document, and this can be of any length. Okay, so the algorithms should accommodate any length input. They're not restricting on them. So we are going to examine two popular algorithm mean for this purpose, which is MD5 and SHA1. So if you look at the diagram, the basic construction of cryptographic hashing algorithm, which can be MD5 or it can be SHA1. In both, they are using the same construction, where if you look at the diagram, we have a compression function, then we have a multiplexer. Multiplexer is getting input from the initial vector and the hash code. Similarly, the computational value of initial vector and hash is given as input to the compressor along with the message. This compression function will obtain the hash code, which is again feedback to the input of compression function. This is the basic structure or construction of cryptographic hash, and it is valid for both the algorithm. So C is compression box, and we are getting the input in terms of binary string of length B and W, where B is the size of bit length of the message, and the W is the bit length of the initial vector which you are providing as input.